The purpose of learning more laws of probability is to be able to give probability models for some complex random phenomena. Probability allows players to see their chances of winning or losing. Also, probability helps determine whether a game is fair, such as coin tossing. Independent events. When two events are said to be independent of each other, what this means is the probability that one event occurs in no way affects the probability of the other event occurring.
An example of two independent events would be, say you roll a dice and then you flip a coin. The probability of rolling a number on the die will not affect the probability of getting a head or a tails on the coin. When two events are said to be dependent, the probability of one event occurring influences the likelihood of the other event.
Let's say you have a deck of 52 cards. If on your first draw you have an ace and you put that aside, the probability of drawing an ace on the second time is greatly changed because you drew an ace on the first time. Conditional probability deals with the probability of an event given that some other event first occurs. Conditional probability is denoted by the following. The above is read as the probability that B occurs given that A has already occurred. The above is mathematically defined as
multiplication rule. A and B both occur. This region is referred to as A intersection B, and in probability, this region refers to the event that both A and B happen. When we use the word and, we are referring to multiplication. If A and B are independent events, the probability of this event happening can be calculated as shown. Suppose we have two dice. A is the event that 4 shows on the first die, and B is the event that 4 shows on the second die. If both dice are rolled at once, what is the probability that 2 4s occur? The probability of A equals 1/6. The probability of B equals 1/6. The probability of A and B equals the probability of A times the probability of B equals 1/36. Conditional probability for two independent events can be redefined using the relationship above to become: the above is consistent with the definition of independent events. The occurrence of event A in no way influences the occurrence of event B, and so the probability that event B occurs given that the event A is the same as the probability of event B. Additive rule, A union B. In probability, we refer to the addition operator plus as or. Thus, when we want to define some event such that the event can be A or B, to find the probability of that event. Suppose a high school consists of 25% juniors, 15% seniors, and the remaining 60% is students of other grades. The relative frequency of students who are either juniors and seniors is 40%. We can add the relative frequencies of juniors and seniors because no student can be both a junior and a senior. Suppose that we draw one card from a deck of 52 playing cards. What is the probability that the card will be either a king or a heart? The probability of drawing a king is 4 out of 52, the probability of drawing a heart is 13 out of 52, and the probability of drawing the king of hearts is 1 out of 52. Therefore, mutual exclusivity disjoint. Two events are said to be mutually exclusive if they can't occur at the same time. For a given sample space, it's either one or the other, but not both. As a consequence, mutually exclusive events have the probability defined as followed. An example of mutually exclusive events are the outcomes of a fair coin flip. When you flip a fair coin, you either get a head or a tail, but not both. We can prove that these events are mutually exclusive by adding their probabilities, which should equal 1.